This class activity is forces acting on drones. So the purpose of this activity is to identify forces and how those forces affect motion of an object, and we're going to be using like drones or a quadcopter as it's flying through the air. So forces acting on drones, it covers the topics of types of forces, free body diagrams, balance versus unbalanced forces, and calculating the net force. So the first four problems are looking at the types of forces acting on a drone, and there are four different scenarios. One, it's just at rest on the table. Two, rest at table, but the propellers are spinning, hovering in the air, and moving forward. So for this, there are six different forces that we've talked about, and that tension force, that there sometimes tension force is split into tension and spring. I just include them. And as a hint, what I've done is I've given you all the different types of forces all the different types of forces and what they are, those definitions. So I'm going to come down here to, I'll do this one, right? Number 4, identify the types of forces acting on the drone as it's moving at a constant speed through the air. So we're on Earth, automatically no gravity is acting on it, right? Normal force, well, normal force is that perpendicular support force. So I know no, there's no normal force. Now, an applied force, yes, I'm going to count the applied force. This one's kind of tricky because the propellers are applying a force upward. Well, actually, the propellers are pushing on the air. The air is pushing on the propellers upward. Now, the frictional force, friction just resists sliding motion. So we're not dealing with friction in this one, right? So there's no friction. Now, drag, as it's moving through the air, there is air resistance that it's going to encounter. So yes, it is going to encounter some drag, and it's not being held by rope, string, or spring, so there is no tension, right? So notice, once I get it correct, turns green, automatically starts counting up the points. Now, these next ones, right? I'm going to do a couple of them. I'm going to do two different ones. Let's just do the first one. Drone is at rest on a table with the propellers off. So in all these scenarios, you're going to be answering these three questions. Is the drone accelerating or not? Is the net force on the drone 0 newtons or not? And are the forces on the drone balanced or unbalanced? And then identify the free body diagram. So if you need any help here, right, I always try to provide a little help there. There are 3 ways to accelerate: speed up, slow down, and turn. If the forces are unbalanced, there is a net force, and the object will be accelerating. If the forces are balanced, the net force is 0, and the object will be at a constant velocity or rest. So let's just look at this first one, right? The drone is at rest on the table with the propellers off. So is the drone accelerating? No, it's not accelerating, right? It's at rest. Is the net force on the drone 0 newtons or not? If it's not accelerating, the net force is going to be 0 newtons. I add up all the forces, they cancel out, which means the forces are balanced. Now, the last thing I need to do is I need to identify the free body diagram. So I have 5 different choices here. Now, I know it's on Earth and gravity is going to be acting on it. Great. Now, I know that there's going to be a perpendicular support force acting on this, right? And that's going to be this one, right? Because that's all I have, right? I don't have any other forces. I've got gravity and I've got that normal force supporting it. And I know that they're balanced, and that's going to be this one. I get it correct. Great. It turns green. All right, let's move on down. Let's not do this one. Okay, let's do number 7. The drone is speeding up straight up off the table. So is the drone accelerating or not? Well, remember, there are 3 ways to accelerate. You speed up, you slow down. In this case, starts on the table at rest, and it's speeding up in the upward direction. It's getting faster. So yeah, it is accelerating, which means the net force is not 0. I add up all the forces, and there's going to be a net force left over, causing it to accelerate, which means the forces are unbalanced. They all don't cancel out. So now I have to identify the free body diagram here, right? So it's not moving like left or right through the air. There might be a small drag force as it's going up, but I only use the drag force as it's flying horizontally through the air. So so it's not this one, not this one, not this one, right? Drag isn't pushing it up, right? Now, you might be tempted to look at this one and say, well, I've got gravity and I've got an applied force. Now, here's the reason why that one is incorrect. We said the forces are unbalanced. In this one, the forces are balanced. So gravity and applied force, they're going to cancel out. Whatever this object is doing, it's either hovering there at rest or it's moving up or down at a constant velocity because it's not accelerating. So it's not that one. I'm going to look at this one. It's going to be this one. Notice the applied force is in the opposite direction, but a little bit larger in magnitude than the force of gravity. So there is a net force causing it to accelerate up in the upward direction. So those are the two different kinds of problems, right? That object is either accelerating or it's not accelerating. All right, so let's scroll all the way down to this next part, which is calculating the net force, right? So let's do a couple of problems here, right? Let's do this one, right? Let's do number 16. This one might be a little bit tricky. And this one, the hints just tell you the net force is the sum of all forces acting on the object. It is a vector quantity, which means it has a direction. If the forces are balanced, there's a net force and the object will be accelerating. If the forces are balanced, the net force is zero, the object will be at a constant velocity at rest. So let's take a look at this one. This one's an interesting scenario. Calculate the net force acting on a drone with a weight of 2 newtons. So weight, force of gravity pulling down, at rest on a table with the propellers applying a force of 1.5 newtons. It's supposed to be in the upward direction, right? So the propellers are on, and it's going the propellers apply an upward force on that one. Now, this one's a little bit tricky, but it's also kind of easy, right? It's at rest, right? Just because the propellers are on, applying a force upward, well, I still have a normal force. I've got the applied force of the propellers. I've got gravity pulling down. They all balance out, and it's going to be at rest. It's going to be 0 newtons, right? So I find that. Now, the direction, well, there is no force, so it's none. There is no force acting on this, right? So let's go ahead and go to another one where we're looking at this one, right? Let's see here to speed the drone straight up off the table. All right, so calculate the net force acting on the drone with a weight of 2 newtons. So that's the force of gravity pulling down. I've got 2 newtons, with the propellers applying a 3 Newton force up on the drone to speed the drone straight up off the table. So now I've got 2 newtons going down, 3 newtons up. So I know that it's going to be accelerating because it's speeding up. I am going to have a net force acting on this object. And if I do this, I know I'm going to have 1 Newton of force, but the direction is going to be up, right? Because it's accelerating, it's speeding up in the upward direction. So that is how you're going to do that for those different scenarios, right? So once again, this is just a class activity that's identifying forces, calculating the net force, identifying free body diagrams, all acting on a drone.